So here we are, Module 2, domain and range. So first we'll talk a little bit about functions, how that's related to input and output. First of all, we do have x's and y's, as we've been talking about so far, the two variables we use. And we have been using the x because when we go to graph, that's what we kind of keep these consistent. We've been using the x for the input variable and the y for the output. Now that's by convention. Somebody decided to do that and we all go along with it so that we can communicate appropriately. This input variable x, we also are going to label it. When we talk about the input, we're talking about a particular value for x. When we want to talk about all the values, we call that the domain. So the domain of the function would be all possible input values, all possible x values. And we do the same for the range. Output is a particular value, but when we want to talk about all potential values, we call that the range. And other symbols we use, of course, we use the input variable x here. We also, in function notation, instead of using y, we use f of x, g of x, some named function with this little input showing that x is the input variable into the function. So multiple ways of doing that. Now, when we start looking at the domain, the reason this is an important feature is we want to make sure that when we put a value in for x, so x equals some number, that number is going to produce an output. So f of question mark actually equals some real number. So as we look at the domain, there will be certain x values that we're not able to get a real value, a real number. And so far we have two instances where that will occur. The first we've sort of addressed when we had complex numbers. Whenever we have a square root, if the input to it is negative, that's going to give us a complex number, or in this case, an imaginary, a pure imaginary. So any input value, whatever's in here, and again, it may be more than x, but in this case, if we're talking about the square root of x has to be non-negative, which means it has to be greater than or equal to 0. 0 is a non-negative number. So that's one of the things we're going to look at whenever we have a square root. We're going to say whatever's inside that square root, and I'll just make it a little bit more generalized, call it a smiley face, that whatever's in there, that its result, once you plug in x and do the math inside there, it has to be greater than or equal to 0. So you're going to see this technique when you see a radical. We're going to have to solve for this inequality. The second place that causes this problem, and it's not necessarily in order, the problem happens when we try to divide by 0. Because 1 divided by 0, if you look at your calculator, it'll tell you it's undefined or error or something like that. And what it really is, the thing is you're thinking, okay, 1 divided by 0, it's got 0. I know 1 times 0 is 0. We're thinking maybe it's a small value, maybe it's 0. We maybe forget. But what's happening when we divide by 0, we're actually getting larger and larger values. So you take 1 divided by 2, what's that as a decimal? It's 0.5. 1 divided by 1, so notice we're getting, the denominator is getting closer to 0, and notice we are getting larger. We went from 0.5 to 1. If we divide 1 divided by 0.5, notice getting closer to 0, we're going to get to 2. And try this one, 1 divided by 0.0001. You'll see that that's actually going to be, it's 1/10,000. So if you take the reciprocal of 1/10,000, you'll see I get 10,000, a very large number. So the closer we get to 0, the larger the number gets. And so we could go ahead and define, say, okay, 1 divided by 0 is equal to infinity, which is accurate, but infinity is not a real number. So this is an area whenever we have some function in the denominator that has an x value, what we have to do is we solve for wherever that function, that x value equals 0, and then we're going to exclude those values. Okay, and we'll look at some examples where that happens. So whenever they're asking about what's the domain, these are the two things we're going to consider. Later in the course, we're going to see there are some other logarithms have an issue, but right now, these are the only two issues we have to worry about. Trig functions will have some issues because of this division by 0, but so far, these are the only two things we're really looking at. If we don't have either one of these things, then the domain will be all real numbers. We could use anything, and we'll denote that as negative infinity to infinity for everything else. Yeah. I think we've got a couple where we'll actually run across that, so we'll just leave that, but just think of that. That's what we're going to get. So just a couple examples. So functions, we've got these functions both here. For each of the function, find the domain. Right. Find the domain. So we look up at f of x. Is it potential that we could have a 0 in the denominator? Could we have, certainly, do we have to worry about square roots? No, there are no square roots, but there is the potential that we could have division by 0. So what we do is we take this denominator and say, when does this become 0? And then we're going to exclude those values of x that create a 0 from this. It doesn't matter what happens in the numerator. Okay, it could be 0 at the same time. It could be 1, 2, could be negative. It can be anything because there's no, we can always, whatever real number we have for x, we can always subtract 5 from it. Okay. So again, looking back, we've solved some of these before. The quadratics, we can solve this one by factoring. Okay, so we will factor into two binomials. Looking at 30 can be made in a multiple ways, but 5 times 6 is probably going to be the best because we're subtracting. When you take 5 minus 6, you get a 1, and that's going to work for us. So we get x times x. We get 5 and 6. We're subtracting, so one's positive, one's negative. And since the middle term, 1x, is positive, the larger number has to be positive. So we end up with positive. Okay, FOIL this out to do a check, but you'll see that that factoring does work. So when we solve this, we get x minus 5 equals 0, or x plus 6 equals 0. Either of those values will create a 0 in the denominator. This one we solve by adding 5 to both sides. So getting us x equals 5. And this one we subtract 6 from both sides, telling us that x equals negative 6. These are two values we have to exclude. So I like to do this by looking at a number line. So negative, so here's 0 for reference. Negative 6 is going to be to the left. Positive 5 is going to be to the right. We want to exclude these values. Those are values we cannot use. And so we can use everything else from here until we get there, and then we can use everything in between here, and we can use everything past this. And what we have, if we went all the way down here, let's go back to original color, we're going to have negative infinity here, positive infinity here. And so what we see is we go from negative infinity to negative 6. Those are numbers we can use. We can't use 6, so that's why we use a soft bracket, an open bracket, parentheses, not a bracket, but a parentheses. And then we've got this group of numbers when we get to the right side of negative 6, the other side, all the way to 5. So we say union, again, negative 6. We're not using negative 6, so this is that's a complicated way, but it's a way to exclude 6. We go from negative 6 to 5. And then we do this union again. I'll do it down here. We go from 5 all the way to infinity. So this is again, a complicated way of writing things, but it is a way of saying not negative 6 and not 5. So this is our domain. Okay, perfect. Now, for the second question, g of x, let's take a look. Could the denominator here ever become equal to 0? So again, that's the only issue, just like the other one, there's no square root. So we say, can x squared plus 64 ever equal 0? For it to be equal to 0, x squared would have to be somehow negative so that it subtracts from 64, right? Because this is positive 64. And whenever, remember, you're going to square. So if you put in a negative number, it gets squared, it's going to be positive. X squared is always a positive number. A positive plus a positive is positive. It can't become 0. That's one way to think of it. And the other way is you could go ahead and say, well, I wasn't sure of that, so let's solve this as best we can. So I'm going to subtract 64 from both sides. That would leave me with x squared equals negative 64. And how do we solve, like when we have a square root? Well, we take the square roots of both sides. And again, when we do that, that's going to give us a plus or minus. However, this square root, since it's got a negative inside, it's an imaginary number. There is no real number that will solve this equation. So what does that mean? We are scot-free, right? With this particular one, our domain, what we say is this can never happen with a real number. This cannot happen with a real number, so that can't happen with a real number. So the domain is everything. It goes from negative infinity to positive infinity. Nothing needs to be excluded. Now, what confuses some people is they get used to seeing that this, when we have x squared minus 64, notice just a slight change in this middle symbol, that will factor into x plus 8, x minus 8. This one, we're going to have to exclude actually both positive 8 and negative 8, right? Because this can become equal to 0. So this one, we need to factor and go forward. It's a difference of squares. But the sum of squares, well, there is no way it factors, so the domain for this particular one is always going to be negative infinity to infinity. But it typically will throw students, I'll see kind of both answers for questions like this one. Okay, so that's domain with excluded values. And now, let's see, why does it do this to me? Here we go. Domain of a square root function. So this is the second type of issue we have. And again, what we have to do is make sure that all this inside stuff is non-negative. So in this case, we're not looking what to exclude so much as what to include. So 4 plus 2x has to be greater than or equal to 0. That's non-negative. It has to be positive. So we go through and we calculate. Now x itself could be negative, but the result has to be positive. So we subtract 4 from both sides, leaving us with 2x has to be greater than or equal to negative 4. Finishing to solve for x, we divide both sides by 2. That gives us 2 divided by 2 is 1, that x is greater than or equal to negative 2. And so this is the domain. It's not what we exclude, it's what we include. So we come along here, we draw our line. There's 0 as a reference. Negative 2 would be to the left. Negative 2 is included. So we're going to include it, and everything else this way that's larger than negative 2 is included. So all the way to infinity. So we list this as, again, because negative 2 is included, we use a bracket, and we can go all the way to infinity. Negative 2 will give us a 0, and square root of 0 is still 0. Right? So we're okay there. That checks out. But anything smaller than negative 2 is going to give us a negative, which gives us an imaginary number. So this thing called interval notation, that's what we're talking about right here. Okay, bracket means included, right? Because of the equals part, and we go all the way to infinity. Okay, so let's look at one where we've got a combination of things going on. The domain of this function. We've got two problems here. We've got both the square root problem and the division by 0 problem. So we'll look at them and we'll make sure that we exclude everything that causes the division by 0 and that we look to include the parts that are positive. So maybe we'll look at the square root part first. Again, don't have to, but what we're looking for is that this square root part inside the square root, x plus 10, that has to be greater than or equal to 0. And so the way we go about solving this, we subtract 10 from both sides, and we get our answer. Our domain is x greater than or equal to negative 10. So I'm going to start my number line. Here's a reference 0. Negative 10 would be over here. Negative infinity is over here. Infinity is over there. Let's go ahead and go with this color. So x is greater than or equal to negative 10. So at negative 10, we have a solid dot, and then x has to be bigger than that. So let's go, it's everything going this way. Now we're not done yet. We've got to take a look at the other part and see if there's anything we need to exclude. But so far we've got negative 10 to infinity as the domain because of square root issue. Now we're going to go ahead and look at the denominator issue. So negative 2x plus 4, we set that equal to 0, and remember this is going to be what we exclude. And if it's in part of this area we've already got, then we'll deal with it, right? So, okay, solving this for x, we're going to subtract 4 from both sides. So we get negative 2x equals negative 4. We divide both sides by negative 2. That becomes a 1. Negative over negative is a positive. 4 divided by 2 is 2, so positive 2. We need to exclude this, because if this happens, remember division by 0 gives us infinity, which is not a real number. So how do we exclude that? Well, we come in here. Let's use hopefully this gives us some good contrast. We'll use a blue. At positive 2, it's right there. We're going to put an exclusionary. And let's see if I can just erase this little part in here. Nope, it erased it all. A whole number line. So we did have all of this. But now what we're going to do is we're going to be sure that we exclude 2. So we're going to go from here to the left side of 2, and then we're going to go from the right side of 2 to infinity. So that's going to give us our 2 pieces of the interval. So negative 10 to 2. Negative 10 is included because of this part, right? It's included, but 2 is not. We've got to exclude it. Then we union that with 2 to infinity. Okay, so that's how we might have to look at both issues of a negative inside a radical and division by 0 when looking at domain. Now, say we got this answer and we had to exclude like negative 20. Well, negative 20 is over here, so we wouldn't even consider it because it's already excluded, right? So that's kind of the thing. That's what we were kind of hoping for. It would have made it real easy. Then we could have just said negative 10 to infinity. But since what we have to exclude is in the part that we had chosen, that part of our domain, we had to come back and exclude it right here. Okay. So almost there. Those are the different types of domain and functions. And now let's just take a look at domain and range from a graph. And what we're doing here is we want to consider, I guess first, what's the domain? So domain is your x values. Let's go ahead and use that one. So what I see is I've got an x value here, and I can go to there, and those are included. There's a space in between, and then I've got x values that have outputs all the way to here. What I'm going to do is come back in and, so this was a solid point, this was a solid point, this was a solid point, but this is an open point. So 4 itself is actually not included. So when I go to write this domain on the x values, it's going only from negative 4 to negative 3. There is a break from negative 3 to negative 2. From negative 2, we go all the way to 4, but we don't include 4 because of the open circle there. Okay, so that's domain from a graph for piecewise function. The range, we're doing a similar thing. Now, if this is on paper and pencil, basically, if you turn it sideways, you end up doing the same thing, but you're doing the y-axis. So let's see, let's do some contrast here. So the y starts from here, goes up here. There's really no break. See that break? Because all the way to here, that's this first part is continuous, and then it picks up. So there's no break here. It goes all the way up to here. And let's come back here. So negative 1 is included. Notice I'm reading y values in this case. And then I go up all the way to 5. All of this stuff in between is included. But when I get to 5, I've got an open circle. So for my range, I'm going to go with a bracket, include negative 1, go all the way to 5, but not include it. And that's all I need to write. There is no breaking period because 2 is included as a y value right here and here. So there is no effect of this break. There's continuous. All right. So that's a piecewise function. And that brings us to the end of Module 2, direct instruction portion. So now you can look at completing the homeworks, assignments, the learning activities for Module 2. And again, any difficulties that you face, look for our online tutoring, our instructional office hours, or work with peers. And remember our discussion forums. You can post questions. And it's helpful if you put a little bit of the work that you started and let us know what you're doing and see if someone can help out with a suggestion to move you forward. All right. Thank you very much.